To understand fractional indices, all we really need to do is look at a couple of facts that we already know and then deduce something from those. So the first fact that we have here is that if you take any number, let's call it a, and you find the square root of it, but then you also square it, you actually just have that number itself, a. Now, we also know, remember the rule that if you take any number and you raise it to a power and then raise that to another power, we've already learnt that you need to multiply the powers together. So if we're thinking, all right, if we take a raised to some power and then we square it, but we need to get just a is a to the power of 1, isn't it? We're effectively asking ourselves, a to the power of something squared needs to be a to the power of 1. Now, something times 2 equals 1. That something has to be a half. There's nothing else that could fit there. So it makes sense that a to the power of half squared gives us a to the power of 1, which is just a, isn't it? So if we know that we can take all of this part and square it to get a, but we can also take all of this stuff in the brackets here and square that to get a, then all of this in these brackets must equal all of that in those brackets. So there we have it. The square root of a is equal to a to the power of a half. So that forms a definition and an understanding of what a fractional index really means. We can do the exact same thing with cubed roots and cubing. We know that if we have any number, and we find the cubed root of that number, there's a little 3 there in case you can't see, and then we cube the number, we'll actually just get a. But we also know that a to the power of a third, whatever that might be, if we raise that to the power of 3, we need to multiply 1/3 times 3, and that gives us a to the power of 1, which again is just a. Now, if both these things inside the brackets can be cubed to make a, they must be equal to each other. So you can see that a to the power of a third must be equal to the cubed root of a. So now we need to just write this as a rule, put a big colourful box around it. A to the power of 1 over n, where n can be anything, if you can see that, it might be a little bit small, is equal to the nth root of a. We can extend our understanding of fractional indices now. We know that when we raise something to a power and then raise that to another power, we multiply the powers together. So 1 over n times m just gives us m over n. But we also know from what we've just learned that if we have something raised to a fractional index number, that's the same as, for example, 1 over n, it's the same as finding the nth root of that number, let the number be a. So if we know that raising to the power of m here, it gives us this, but we also know what this expression is, it's actually the nth root, then if we want to take this part, raise it to the power of n, which, as we've done here, is exactly the same as taking this and raising it to the power of m. So this part here gives us this, and we can see that if we have any number raised to a fractional index where we have a numerator and a denominator that are not necessarily 1, so m and n here are just constants, what we need to do is we can express that as, well, we know what to do with the number on the bottom, that the n down there becomes the nth root of the number, but then we have to raise to the power of m, which here is the numerator. Now, the order doesn't matter, so this expression here, where we've taken some number a, we've found the nth root of it, then we've raised it to the power of m, that's exactly the same as taking the original number a, raising it to the power of m, and then finding the nth root. They're exactly the same as each other. So let's put a box around that and put that in our theory notes.